My name is Maria Kennedy. I'm Professor of Water Supply Engineering here at UNESCO IG in Delft in the Netherlands. And on this project we're responsible for Work Package 8, which is the dissemination of the results of the project.
Victor Monsalvo from Aqualia. I'm the head of the co-efficiency area at the Department of Innovation and Technology. Aqualia is the coordinator of the MIDES project, and we try to keep all the efforts together from our excellent partners to reach the goals established in the project.
My name is Abdsalam Al-Hadidi. I work for Fujifilm Corporation, located in Netherlands, and we mainly responsible for the development of the ion exchange membranes for MIDES project.
Marta Juaniceda. I'm from working for Leitat. It's based in Barcelona in Spain, and I'm the technical responsible internally coordinating all the activities in Work Package 1 and 2, a little bit on 3 and 4 as well, and we are focused on the material development in the electrode and also in the membranes.
My name is Juan Manuel Ortiz. I come from India Water. It's a research institute in Spain, and my responsibility in this project is Work Package 3, is the development and the design of microbial desalination cells.
My name is Almut Schwenker. I'm working at SGL Carbon, a German-based company who is manufacturing everything out of carbon and graphite materials, and we are part of the Work Package 1.
My name is Fatima Dargan. I work for Simtech Simulation Technology in Graz in Austria. In the MIDES project, our responsibility is to play the role of process simulation and analysis using the simulation software from our company called IPSI Pro.
I'm called Pedro Souza. I'm from On Control Technologies, and my responsibility is to develop the control infrastructure of the MIDES project.
My name is Sabran Esteve. I'm working at India Water, which is a water technology institute fully devoted to water technologies in Madrid, in Spain. In MIDES project, I'm the scientific and technical manager. So I'm trying to help an inspiring team of people to put all the pieces together in order to be MIDES a successful project.
Well, nowadays, I think that we are having good results. We are producing more desalinated water than established in the literature at the moment. So I think this is very good.
Well, we have identified in both work package some lead candidates, and we have improved the productivity of the electrodes, and also we think we have better membranes now for the application. Now we have to work a little bit on the scale up.
We screened a lot of different materials and supplied them to the partners who did first tests, and we get some good knowledge now about what kind of materials are suitable for the desalination cell.
Let's say the progress are really very promising. So we have a lot of development that we have seen and we have tested. We have confirmed those kind of advantages and advanced properties on the membrane.
Well, the MIDES concept is absolutely revolutionary. Give us the opportunity to optimize and to valorize two different streams, saline streams and wastewater, to produce drinking water and treated water to different purposes like environmental uses.
The main concept or the original idea is to lower the energy consumption of the RO, and that's by lowering the salinity in the feed by using the geobacter actually, or the bacteria as a source for free electricity, in this case to desalinate the water as a pre-treatment step for RO. That means the cost in general for drinking water will be less.
many aspects can be involved in there. The consortium is just great, very complementary, and the competencies are really bringing to every one of us some new feedbacks and so the consortium work is very positive.
I think the most interesting thing from this project is the capacity of using a very old ability of bacteria to generate energy from their own natural resources and combine this with a biotechnology application that's going to make thirsty people be able to get drinking water almost for free.
One of the biggest problems about using seawater to produce fresh water is the energy consumption which is used in the process. So by having a low energy method of desalinating seawater, we make it readily available, in fact, which means the costs are lower, the environmental impact is lower. That means it can be used in many, many places where currently we wouldn't be able to use it. So if there's a conflict somewhere where the high cost is currently prohibiting the use of seawater desalination, then MIDES has a solution for that, in fact.